All right, so good morning, everybody. I'm really glad to be here today and also to follow the previous speaker, because actually the research talk that I'm going to give has some clear connections to the previous talk. However, I'm going to approach this really from a computer science standpoint, which is my background. So I'm a computer scientist here at the Vrije Universiteit, interested in user-centric data science. And I'm going to talk a bit about a specific type of technology and solution to representing data and knowledge, specifically knowledge graphs, but also relate that to one of those challenges that was introduced by the previous speaker. Let's make them useful for users in the global south. And in the past, we've been working on specifically identifying and working on 3 specific challenges. And more recently, and currently, we're looking at this also from a 4th angle. So I'll leave that last. All right, so knowledge graphs, what are they and why are they here? So they start from a realization that, of course, we as a humanity, we're making more and more data every day, and data is being created by artificial agents, by ourselves, on all kinds of topics. And of course, they have been this has been going on for quite a while, both in government, social web data, medical data, and also, for example, development data, which might be useful for these people in the global south. And of course, this data is interesting for machines to do things with, like predict things, do analytics, visualizations, etc. However, usually these data are more or less siloed. And what we would like to do is to move away from these silos and actually connect them to show that we can do new, interesting types of analyses. So we have this tool since the 70s, the internet, made possible by connecting these machines that have silos in them, these databases. And since the 90s, we have the World Wide Web, that allows us to connect specific type of data in the form of documents. So the World Wide Web basically is a way of connecting individual documents that are meant to be read by humans and connect them using these web links. And that has proven to be a very simple but very powerful technology to really connect knowledge that is in different places in the world. And what we would like is to not only do this for documents that are meant for humans, but also for raw data. So instead of a web of documents, we're looking for a web of data. Instead of linked documents, we're looking for linked data. And that is where this term semantic web, linked data, or knowledge graphs come in. Right? So it's basically just individual databases that are connected by connecting the elements in those databases using web links. And then applications can do interesting things. So how do we actually put the data in these? How do we describe the data in these databases? So instead of the more traditional relational database, here a more network model in the form of a knowledge graph is actually quite useful, because it allows us to more flexibly connect individual elements in those knowledge graphs. So we can use actually the links between elements such as the Netherlands and Amsterdam, or that Amsterdam is a capital, and we can represent it in a network that can more easily grow. They're more flexible and more versatile in a way than relational databases. Of course, there are, let's say, technical challenges of making this work, and sometimes relational databases are great, but now we're focusing on this more web sharing thing, and then knowledge graphs actually are very useful. So they're not only theoretical, we actually are building them. So they're have proven to be very useful ways of representing raw data, but also more knowledge, right? More higher level interpretation of that data. Especially they're useful when you have heterogeneous data. So when you have data from different, with different purposes, original purposes. So again, here, this allows us to step out of those silos. It allows us to represent explicit meaning of data. So we can say that things are of a certain type, or that certain relations can only hold between things of a certain type. But it uses this graph, this network, to represent data. And I think most importantly, it allows us to do this on the web at the web scale. So we build basically on top of the web infrastructure to share data, knowledge, and information in this way. And we have knowledge graphs about basically everything, right? About movies, about music, about geographical information, etc. And they are actually being used not only in academia, but also in industry. So we now see that basically all the big data companies, they combine their information in knowledge graphs. Museums do this, companies like Netflix. So we find those everywhere. So this is my colleague Frank van Harmelen's good news slide that of companies and industries that are using this, and it's getting fuller and fuller. So that's great. But how can we actually use those for, let's say, for social good, or specifically for social good in the global south? So we've been actually developing specific knowledge graphs for this, and not only us, but also at larger scale. So one of the big success stories here was the publication of 2 knowledge graphs, AgroVoc and AGRIS, by the FAO. So this big United Nations organization, and that sort of presents their knowledge about plants and about all kinds of information on farming in these publicly available knowledge graphs, which can then be used in all kinds of applications down the line, and can use by everybody because this is open knowledge. Well, another example that we've been actually developing here at Vrije, this was specifically a master thesis a few years ago, and it allows me hopefully to show you a little bit how it's actually useful. So this was about converting existing tabular data in this knowledge graph form. And here we looked at information from the International Aid Initiative, the Transparency Initiative, that publishes information about aid activities in the world. And what we did is we converted that to this knowledge graph form, and that allowed us then to link it to other existing knowledge. For example, geographical knowledge. Right? So information about specific aid activities in a country can now be linked to information about that country. And now we know, for example, we can plot the aid activities on a map. Well, it's a very simple thing, but we can also do all kinds of analyses about which countries receive more aid, about specific topics. We can also link that information to other information related to aid or activities, for example, to information from the World Bank. And hopefully now you see a little bit that this data that comes from really completely different sources allows us now for new kinds of analyses, for example, on the effectivity of aid. So this hopefully shows a bit the power of these knowledge graphs. So that's still nice. We can build these nice user applications that show you these correlations, for example, in nice graphs, as you see here on the bottom right. However, one thing that we also are concerned about, and I think the previous speaker addressed that, is how we actually connect to people that might need this information, the people that are talked about rather than the people that are talking. So what we want to investigate is how to avoid or circumvent or build a bridge to cross this digital divide between, let's say, big data, big knowledge graphs, and people in the global south. We've been doing this with the colleagues to my left and my right here in specific instances in the global south. So what we've been doing is specifically identifying the main challenges for bringing this knowledge in the form of knowledge graphs to people in the global south. And we've been doing this over the course of a number of courses, workshops, conferences, papers, etc. And we've come to these 3 challenges. So one is that we need to make knowledge graphs usable in low resource and low connectivity context. So that means making sure that they are also usable on appropriate infrastructure. That might include mobile phones or low power hardware that can be powered by the solar panels that we've seen. So that's infrastructure. So then there's a challenge about interfacing. So we need to make sure that these are available to people with low or no literacy, but also in languages that might not be, let's say, Dutch or English or Italian. And also specific to various cultural backgrounds. And then thirdly, very importantly, we need to also make sure that these work for cases that are relevant in these regions. Right, so not just maybe high-level aid information, but also things that people can actually use on the ground. We've been exploring this in various cases. I'm going to share one case with you, which is a case that we've been working on for a few years now, about market information in the Sahel. Specifically looking in Mali, about how we can use information about product offerings by people that work on non-timber forest products, such as nuts and honey, and actually make that information available locally so that they can more easily sell their produce. So one thing that we've been doing is developing knowledge graphs such as these where not only information about individual offerings can be stored, right? So, for example, this is an offer for 1,000 kilos of shea butter, but also to actually have audio information in specific languages such as Bambara, which is a local language, or French. So this can actually be used in applications that are voice accessible. So people can actually phone such an application and make selections to either to access these offerings. And so in a way, we can then use this knowledge graph to build these sentences that somebody can actually listen to an offer of 15 liters of honey offered by some person that can be played on the radio or accessed through a voice interactive system that can be called using a normal phone and a normal phone number. And so in that way, we've been looking at new ways of interacting with these novel technologies in knowledge graphs. At the same time, we also need to take this infrastructure challenge into account. So we also want to see if we can actually build all this on very simple, cheap, reusable hardware. So enter this very simple Raspberry Pi with a GSM dongle, with some appropriate software on it. We call it the Kasodaka, something that we're developing with colleague André Baert, to build all this using this small hardware. And another thing, then maybe we have information in one area and we want to combine it with information in this other area, again, bridging these silos. So can we do that using the, let's say, the low power network that are available, for example, in rural Mali? So for that, we've been looking at, for example, sharing information between knowledge graphs using SMS network, right? So not high powered fiber optic cables, but existing networks for phones. And indeed, we can show that for some cases, it actually makes sense to share information using this very slow and very, let's say, expensive networks, because it outweighs the costs of putting new cables in the ground. So those are the three challenges, right? So we looked at infrastructure, interfacing, and relevancy. And more recently, we've also been looking at fourth challenge, polyfocality. Because one thing that we are seeing now more and more in these real world knowledge graphs, not only the ones that are specifically related to the global south, but also here, we've been working a lot, for example, with museums. And what we see in those knowledge graphs that are being created is that they usually come from some existing database. And now that these databases, we can challenge whether they actually represent a global or a neutral point of view. And what we've been learning from, let's say, recent things in the news about machine learning is, no, they don't. Right? They usually contain biased, univocal, so information from one point of view, single view information. So for that, what we need to do is to consider whether we can actually build and identify these multiple voices in these original data sets to build knowledge graphs that actually represents a more global view. So where we're doing that now currently is more in a local project, the Pressing Matter project, where we're looking at Dutch art that was actually now here and taken from ex-colonies. And we want to figure out, so the descriptions of those things that we have in the current databases, are they actually accurate? And do they not represent a specific colonial point of view? The answer is yes. But how do we recognize these things? And how do we actually make sure that we can actually represent this information that is polyvocal, right? So something can be loot, or it can be gift, or maybe it's both. Maybe it was a gift, but in a specific cultural context. And maybe objects mean different things to different people at different times. So all of these, the answers are yes, but how do we actually represent these in these knowledge graphs? So that's something that we are investigating now. Identifying and acquiring polyvocal knowledge, representing it, and then presenting it. So let's skip this for time. So just as a wrap up, what I'm working on is these knowledge graphs, which are very powerful and useful ways of representing and sharing knowledge. But we need to make sure that they're accessible to everybody. So we need to work on infrastructure, we need to work on interfaces, we need to work on relevant use cases. And then fourth, we need to understand actually what kind of point of view these data sets represent. So I hope I made you enthusiastic for knowledge graphs, but also for critically assessing the technologies in this way. And for that, we really need these
these multi-approach strategies. Challenges. So thanks a lot. And if you have any questions, I'm happy to answer. Thank you.
Okay, the floor is open for questions, and thank the speaker. I'm watching also the chat, so, or just raise your hand. I see a hand by Anna, and that's not the same one as previously. So Anna.
Here. Victor, thank you very much for a great talk and very interesting, and it fits so well in the, let's say, the globalizing world in which things have different meanings and biases are actually unmasked, as to say. So that is very interesting, and of course I know your research because we have worked so long together. But do you think that this way of graphs, so say looking at searching the space, the data space, or the semantic web space, that how do you see the future of it? Let's say when we have more access to even more cultures or even more types of meanings.
Yeah, thanks.
Now you can hear me. Yes, thanks for the question.
Yeah, so indeed, this
data space is growing, and not only in the form of knowledge graphs, but just in general. So what we do see is indeed that we have multiple
points of view emerging. However, what you also see is that there is this danger that let's say all kinds of algorithms and sensors,
etc., are pushing more data from a specific single point of view into the world.
And of course, that where all these sensors and data producing algorithms live is in the obvious places, so in the West and in China. So we have those points of view, and that's already an interesting challenge of connecting them. But of course, what we want is to have some global technology that works. So I think with this growing availability of data, we will get some growth in variety, and that brings all kinds of challenges. So how do we know that what I think is an idle image, that it's meaning the same thing as somebody who is from the Democratic Republic of Congo, for example? So that means talking to people, right? It doesn't mean the pure data science. It means talking to people and understanding
cultural and historical context.
But then still, we need to make sure that this
data actually
emerges and
becomes available. That will be a challenge to sort of not let this balance of data production disrupt the data that we have now. And I think that's a big problem. So we've seen this in machine learning, like computer vision, for example. We have these famous examples where automatic sliding doors have trouble recognizing people's skin tones, not because they are programmed to be racist, but because they have been trained with data that comes from. That's a very obvious example.
But I think what's probably is below the